XY1000 in the mail today. Have a charge controller, dump load. It's for the this is the collar for the neck. This is for the generator. Oh man, it's heavy. This is made from all cast. Feels really heavy duty. Oh man, that's easy to turn. Generator right here, and the tail comes attached to it. It's all solid metal. It's also metal. Pretty heavy duty. Feels cast. Nose cone. Looks like we got all the mounting hardware. Some of it's loose. And the wind blades. Oh man, they're heavy too. 1, 2, 3, 4, 5 blades. Alright guys, here's a little short video about the I just wanted to see what kind of voltage this would actually put out. So I just took my voltmeter and I just have it connected right down there onto the collar. And I'm just gonna spin this thing just very slowly with my hand. 8 volts. 6. And I'm hardly turning it at all. It's nothing. So this wind turbine is definitely going to be able to produce some power.
Yeah, I'm right at the turbine here. We're getting our low wind startup. See what we're getting for wind speeds. I wanted to show you the low wind startup of this turbine. It's amazing. It doesn't take much to get this thing going, and once it's started, it stays going for a while. Wind died right out. The blades are still going. What's really low about these blades is they go for a while after the wind dies out, as you can see. And then the next gust that comes through gets them going again. So you're not wasting that energy. There's a lot of blades, I've tried them. Tried quite a few. There's a lot of blades that die out as soon as the wind dies out. These don't do that.
Hey y'all, here we go again. It's a video of my new WinMax HY400, 24 volt now. It's a 24 volt HY400 WinMax. I love it. And I'm going to go inside and show you what I got. And right now the wind is blowing, and it's slowed down about 3 miles an hour right now. And it's picking back up. But like you see, it's barely spinning. Let's get close up on that. But yeah, Leave Me Electric also leave me video on YouTube. He recommended these things to me. And it is a great system. I tell you, I'm not a salesman, neither is he. The wind turbine. She is cranking. She is cranking. But yeah. Anyway, let's go inside the shop, y'all. Alright. Right now she's blowing. Went down to 8. 2.2 amps. Okay. 14 mile an hour wind. And it's just a constant good amperage. 3.3, 4.4. And let's say we're getting about 10 to 15 mile an hour wind. Oh yeah. Well, hey, thank you, Larry.
Uses what's called the SH3045, which is a specially designed airfoil just for small wind systems. Next to the set of metal blades for the WinMax HY400, you can see they have a very thick cord down near the root to help with the startup speed, and then they taper them out to the tips to allow some performance trade-off at the higher end. Next is the Ventura 750, which uses basically bent aluminum blades, which are heavily undercambered at the root section to allow quicker startup without sacrificing too much drag at the higher end. The same approach is used by WinBlue.
I thought I would try to use these power curves that we have been drawing and see if I can come up with a way of calculating out the annual power production for a number of small wind turbines.
So power is in the wind, watts per square meter, 0.6 times the velocity, measured in meters per second cubed. You can make up a quick table in meters per second. Here's the power in watts per square meter. There's the Betz limit, which is the maximum power that a machine can derive from the wind. No one's ever come close to this number yet. Typical turbine does about 35% of what the wind can provide. And so here, this is kind of the table that you'd expect. This is what it looks like. We've got, this is what the wind itself is able to provide, power per watts per square meter against meters per second wind speed. This is the Betz limit. And this is what we'd expect for max produced, which would be about a 35%, is kind of the state of the art currently. So then I took a look at the power curves that I've collected, and I've selected several of them that will study basically what their efficiency is and the airfoil that they're using to come up with just kind of a comparison of what they do efficiency-wise. On the low-end side, I've chosen the WinMax HY400 and the WindBlue Breeze, both the kind of the state-of-the-art for a small wind in the 500 watt or lower range. The WindBlue being one that's based on a car alternator, where the WinMax being based on a ground-up design for both the turbine and for the blades. On the other side of the spectrum, I decided to choose the Windura 750 and the Burgee, and see how they look efficiency-wise.
On this WinMax, now they spent a lot of time designing these blades because they're trying to provide superior performance down at the lower wind speed, which is really the most where most people have their wind. They don't have, unless you live on the coastline or on top of a mountain, you're not going to see a lot of wind. So they realized that and realized they had to customize the blades to be more effective at the low end. One thing they did is they started with a true semi-symmetrical airfoil. So the whole blade is like an airplane wing. If you actually look at the wing section on the end here, it's a semi-symmetrical airfoil. They also use a very large root cord right down, the middle, near where the hub is, and this has two effects. It allows the turbine to start in lighter winds to get spinning, which is a common problem, and it also allows it to operate very efficiently down at the lower wind speeds. And actually the data shows that it actually at the lower wind speed is actually be able to perform with a coefficient of performance over 35%, whereas all the other ones are in the 20% range, 20-25%. So if you're spending a lot of time spinning at the lower wind speeds, this unit here will actually provide a lot better overall production over the course of the year.
Okay, here's the results. Turns out that the most efficient turbine blade combination using the power curve that's been published is the WinMax HY400, because of its deep camber at the down near the rotor hub. They can kickstart and get started a little earlier than others, and they're able to extract about 40% of the power out of the wind right at this 10-mile-an-hour level, which is quite good. And I think other people have recognized how well this is, because the majority of people are in areas that 10-12 miles an hour is about what they see. Yeah, occasionally you'll see higher speeds, but it's really where the money is made is down here. Electricity is made is down here in the low 10 to 15 mile per hour range. So they do quite well in this range, and they stay quite efficient in the mid to low 30s all the way up till about 23 miles per hour, and then start to taper off. So as a design engineer, you'd like to have a nice, relatively flat performance efficiency-wise through this range here, knowing that at some point that you're not, you're going to have to trade off efficiency, and that's why they all seem to tail off here above 20-25. The next best one is this Burgee, which is a quite expensive unit. It's about $3,000 professional unit, and it also does when it gets up to speed, it's quite efficient up in the 35 range, and starts to tail off from there.
Just add up, we get the 650 for the WinMax. We end up about $882 for a car PMA system equivalent. Now, as I mentioned on my other videos, if we rate these at the 11 meters per second, which is 24.6 miles per hour, the WinMax comes in at 425 watts, the car PMA at 250 watts. So if we just look at the dollar per watt, it's only $1.53 for a WinMax system, but you're paying $3.53 for a car PMA on a per watt basis. If we look at the dollars saved per year estimate, and I covered this in one of my other videos, you'll save about $225 in an area that has about a 12 mile per hour average wind speed using the WinMax generator, where you'll save about $150 per year
with a current PMA system like this. Given that, you'll have a payback period of about 2.9 years with the WinMax and about 5.9 years for a car PMA system.
The tower's up, as you can see. And we got both generators up and running. Right? Well, you can't really tell, but they are really spinning fast right now. But they're spinning as fast as the refresh rate on this camera, so you really can't tell how fast they're spinning, but they're going very, very well.
HY 500, 24 volt, and the wind's blowing from the southwest. And there's my WinMax. There's my SWI, 500 watt, 48 volt, right there. Got 5 blades on it, and it's doing a heck of a job. And this is my new WinMax 400, HY 400, but it's capable of up to 500 watts. I'm just experimenting, trying a little bit of everything. But my buddy Larry Leamy of Leamy Video on YouTube, also Leamy Electric, he recommended this wind turbine, and so far I am very pleased with it. It comes out here with 2 stainless steel exhaust clamps. And there's my wind turbine, hardly no vibration at all. And that's my panel and everything. And right down here, you take that bolt out, right there, and that'll take out the panel. Take out the, you can flip the whole tire down after you take that stand off, clamp off. But she does a really good job. Okay, well, y'all have a good one, y'all. Thanks for watching. All right, bye-bye.